Hello everybody and welcome to our fourth and last lesson in Unit 2, Absolute Value and Piecewise Functions. In our previous lesson we discussed how to solve an absolute value equation graphically. For today our objective will be I can solve absolute value equations algebraically. So let's get started. To solve an absolute value equation or inequality algebraically, there are three easy steps to do this. The first step is to isolate the absolute value term. The second step is to write two equations or inequalities. And then in our last step, we will solve the equations or inequalities and check for extraneous solutions. You remember when we talked about extraneous solutions in the previous class? Those are solutions that we cannot find on our coordinate plane and therefore they're not valid. Alright, here's our first example. Solve the inequality. The absolute value of 2x plus 7 is less than or equal to 15. The absolute value term needs to be isolated, but as we can see, it already is. So that first step conveniently has already been done for us. Now we're going to write two equations, two inequalities, excuse me. And remember, what does absolute value actually mean? Absolute value means that whatever is inside the absolute value bars was either already positive, so nothing really happened by putting the absolute value bars around it. So we're going to write one inequality where that term is positive. And the other option, the other possibility is that the whole thing was negative before and the absolute value bars turned it positive. Those are our two possibilities. And when we write the negative part, please remember and make sure that the negative sign counts and encompasses the entire expression. And now let's go ahead and solve these two inequalities. Subtracting 7, we get 2x is less than or equal to 8. Divide by 2, and x is less than or equal to 4. On the other side, we need to remember to distribute the negative sign to both terms. We get negative 2x minus 7 is less than or equal to 15. Add 7. Negative 2x is less than or equal to 22. Now when we divide by negative 2, remember we need to switch the inequality symbol. So therefore x is greater than or equal to negative 11. We can show these solutions on the number line like this. From left to right, starting from negative 11, putting the 0 in just for orientation purposes, and go to positive 4. The two borders are part of the solution, so we're using closed circles, and we're going from negative 11 to positive 4. And this is our solution set on a number line. Let's go to the next example. The absolute value of 2x plus 1 is greater than 7. Again, conveniently, this first step has already been done. The absolute value portion is already isolated. So let's write our two inequalities. 2x plus 1 is greater than 7. And the other one would be negative. And when I say negative, I mean the entire expression. So I'm going to put it in parentheses first. Negative 2x plus 1 is greater than 7. Let's go ahead and solve this. Minus 1, 2x is greater than 6. Divide by 2, x is greater than 3. And the other solution, we have to first distribute the negative sign. We get negative 2x minus 1 is less than 7. Add 1. Negative 2x is greater than, did I say less than before? Greater than 8. Divide by negative 2. X, and now we switch the inequality symbol again, is less than negative 4. On a number line, the solution set would look like this. From negative 4, here's our 0, positive 3. X is either less than negative 4, so we got an open circle on this side, the arrow pointing to the left, or it is greater than 3, another open circle, and the arrow points to the right. We could also write the solution set in set notation, and then we would write open braces x such that x is greater than 3 or x is less than negative 4. And in interval notation, we would write open parentheses, negative infinity, comma negative 4, open parentheses, and then our unity symbol, which you know from last year's or this summer's geometry class, open parentheses, 3, positive infinity. Remember that for negative and positive infinity, we always have to use the parentheses, and for the negative 4 and the 3, we use the parentheses this time because of the open circle, because the inequality symbol did not have the equal to part. Let's move to our next example. So as we can see here, actually the absolute value portion has to be isolated first. So let's go ahead and do this. And remember, from solving equations, first we have to get rid of our negative 3. First we have to add. Then we get 2 times the absolute value of 4x minus 5 is greater than or equal to 30. Divide by 2. 4x minus 5 is greater than or equal to 15. Now we're going to write our two inequalities. 4x minus 5 without the absolute bars is greater than or equal to 15. And negative 4x minus 5 is greater than 15. Go ahead and solve this. Adding 5 on both sides. 4x is greater than or equal to 20. Divide by 4. X is greater than or equal to 5. This is one of our solutions. And let's move to the other side. Distribute our negative sign. Negative 4x plus 5. 2 minuses make a positive, remember. Subtract 5. Negative 4x is greater than or equal to 10. Divide by negative 4. X, and again, don't forget to flip the inequality symbol. X is less than or equal to negative 5 halves. With the flipping of the inequality symbol and the dividing by a negative number, you have seen the pattern already, or are starting to see the pattern, aren't you? So let's move on to our next example. Here we do have to isolate the absolute value portion first. 3 times the absolute value of 2x plus 5 plus 6 is less than 3. Subtract 6, and we get 3 times the absolute value of 2x plus 5 is less than negative 3. Divide by 3, and 2x plus 5 is less than negative 1. So let's get started to write our separate inequalities. But wait a minute! The absolute value of 2x plus 5 is less than negative 1. Let's think about this for a second. As we know, an absolute value bar always turns everything to a positive, right? So how can the absolute value of anything be negative or even less than negative 1? Well, that's a good question, isn't it? The answer is there is no solution to this inequality. No solution. Remember, if ever you have an inequality or an equation where an absolute value is supposed to be less than or equal to a negative number, there is no solution. Well done, guys. Now let's move on to the next one. This one is an interesting case because you have absolute value terms on both sides of the equation. You may think that that means that we have to have 4 different options that we solve all the way through. Actually, it's the same as before. We only need 2. So going through our steps, we know that we don't have to do anything to isolate the absolute value term. Now let's move on and write our 2 equations. First one is going to be positive. 3x plus 3 is equal to 2x plus 5. For our second equation, we are going to pick one of the 2 terms. Doesn't really matter which one. I'm using the left one and making that one negative. And the right one stays positive. And now, as we have done before, we move on and we solve both equations. Subtract 2x on both sides, we get x plus 3 is equal to 5. Subtract 3x is equal to 2. Moving to the other side, we're going to distribute. Always remember to distribute your negative sign to both terms inside of the parentheses. We make this mistake a lot, and it's a shame because we know better, right? So, adding 3x to both sides, we get negative 3 is equal to 5x plus 5. Subtract 5. Negative 8 is equal to 5x. And then we divide by 5. In other words, negative 8 over 5 is equal to x. Those are our 2 solutions. Now let's think for a minute. Why did we only need 2 equations here and not 4? One where we have the left side positive and negative, and then the right side positive and negative. Well, here's why. The equation to the left has both terms positive. Now, imagine you can do anything to an equation that you want as long as you do the same thing to both sides. You could have multiplied both sides of that left equation by negative 1, and now you would have had 2 terms that are negative. But basically, that's the same as the 2 terms that are positive. And similarly, if you look at the equation to the right, one of the terms is negative, the other one is positive. Multiply the whole thing by negative 1, and now the negative one is on the right side and the positive one is on the left side. And also, again, this is the same as the case that we have shown on the right. So just as in all of the other cases, two equations or inequalities, as it were, that's enough for us, and we can go ahead and solve. Now we are going to do one more thing now. We're going to check our answers, make sure that there are no extraneous solutions. You can do this in the left margin of your note page. Let's check the solution 2 first. The absolute value of 3 times 2 plus 3 is equal to the absolute value of 2 times 2 plus 5. 3 times 2 is 6 plus 3 is 9, so the absolute value of 9 is equal to the absolute value of 9. 2 times 2 is 4 plus 5 is 9. Check. Nice. And now the other solution, negative 8/5. The absolute value of 3 times negative 8/5 plus 3 is equal to the absolute value of 2 times negative 8/5 plus 5. The next step, I'm turning all into fractions with denominator 5. So we got negative 24, 4/5 plus 15/5 is equal to the absolute value of negative 16/5 plus 25/5. That means the absolute value of negative 9/5 is equal to the absolute value of 9/5. And as we know, that's exactly what absolute value bars do. Both absolute values are positive, so the second solution checks out as well. All right, let's move to some word problems. Yay, word problems. All right, a regulation basketball should weigh 21 ounces with a tolerance of 1 ounce. In other words, it can be 1 ounce less or 1 ounce more. Write an absolute value inequality describing the weights of basketballs that should be accepted. If we use W for weight, then we think about it like this. The weight of a specific basketball, if we take 21 ounces away from that weight, that will be how much it's less or more than our regulation weight. But if that difference, positive or negative, is less than or equal to 1 ounce, then we're fine. So that would be your inequality, the absolute value of the weight minus 21 is less than or equal to 1. In other words, say the weight was 22, then that would be fine. And if the weight is 20, that would also still be fine. B, what would you need to change in your inequality for basketballs that should be rejected? Well, first of all, we're not going to change anything here because that gave us good information we needed. But now we're thinking about basketballs that are rejected. In other words, they are more than 1 ounce heavier or more than 1 ounce lighter than the 21 ounces. In other words, we use greater than. The absolute value of the weight of the basketball minus 21 is greater than 1. All right. Let's move on to the next example. That's a little different. A sleeping bag manufacturer advertises that one of his models is best suited for temperatures between 30 degrees Fahrenheit and 60 degrees Fahrenheit inclusively. Write an absolute value inequality for this temperature range. Well, this is a little different because it's not giving us the midpoint. We have to find our midpoint first. But what better thing to do than using a number line, right? So we got 30 degrees on one side and 60 degrees on the other. And that's the range within which that sleeping bag works. So, well, we're going to now have to find the exact midpoint between 30 and 60. With a little bit of math, we figure out that that has to be 45, right? And now we got the midpoint, but we also need to understand what are the ranges in both directions. From 45 to 60, we got 15. And from 45 to 30, we also got 15. And when I say 15, I mean distance. That's why the numbers are positive, right? All right, using our midpoint, which is kind of equivalent to what we had up there in the previous problem with the 21 ounces of weight, we are going to say the absolute value of T for temperature minus 45 is less than or equal to 15. Within this range, those sleeping bags work well, and you are not gonna freeze to death or get totally sweaty. All right, that's it for today's lesson. Please take a minute to write your 20-word summary, and I will see you in class.